Okay, so we are on our tabular, right? I think I said that right. On tabular reasoning. And so basically what we're doing, we're asking to describe what's happening with this table. Okay. This is a non-calculator question. So with the non-calculator question, it's sometimes good to just kind of sketch it out the plot the points to see and be able to describe what's taking place. So that's what I'm going to encourage you to do is to make a little sketch. It does not have to be perfect and nothing is fully accurate just as long as you understand where things are falling. Okay. Because I have 0 and -4, I know that that is on the somewhere way down here, right? On my y-axis. Agree? Okay, then we're going to come all the way up here to 2, which is going to be on the x-axis because it's at 2, 0. Then we're going to go to 4, and 4 is somewhere up a little higher at 8, somewhere up here. And it comes back down to 6. And then at 8, it's going to do what? Goes further up. Okay, is this perfect? Do the actual y values matter? No. The goal is to try to create a sketch of what's taking place. Not to erase everything I just wrote, but you know what? One of these days they're going to actually give me my program that I need so I can stop using PowerPoint. No offense, PowerPoint. I love you to death, but the writing just isn't my friend and it doesn't let me do a lot of things. How can I do this? mute myself so I don't forget. All right, so we are back for real, trying to learn now. Okay, so when we look at this, we can clearly see where our maximums and minimums are. So that's why I strongly encourage you. So like, even though you're given a table and they want you to analyze the table, I'm going to strongly encourage you to draw a sketch. And the reason why I draw the sketch is because it makes it way easier for me to analyze it. Okay. Again, if you are cooler than me and you don't need the sketch, that's fine, but I do. All right, so it says part A, the polynomial P of X has a local minimum at one of the points in the table. Where does the local minimum occur? Well, because I have a sketch, can I easily identify it? Yes, I can. My local minimum happens right here at 6, 0. Even though, it's not drawn accurately, you can, that's where it's at, right? That's my local minimum. Okay. So, how do I know? So I'm going to write local min of P of X is at 6, 0. How do I know that? Well, one, since the domain, what's the domain of this? What's the domain? I'm going forever to the left and right, guys. There we go. All real numbers. Since my domain of X is negative infinity, that's a horrible infinity symbol. Negative infinity to infinity. And we can read the graph. So as we're reading our table, what happens from here to here? So we are increasing. We increase from where am I increasing, guys? Somebody, anybody? Somebody. So we increase from 0 to 4. Well, infinity, technically. That's not part I. Where are we increasing around the minimum? Sorry, around the minimum. Where's my increase? From 6 to, from 6 to infinity, right? So we increase from 6 to infinity and decrease. I wrote it backwards and I apologize. I should have wrote the decrease first because on a minimum, what happens first? You decrease, then you increase. So I apologize for inverting those things in my brain. And we decrease from, where are we decreasing? From 4 to 6. So therefore, X, have y'all? No, we haven't. This right here is the lazy writing then and therefore. Then and therefore at X equals 6, the min value is 0. Okay, that was really hard to write. I was trying to write in as least amount of words as possible, and that's all I could do. All right, so following that same logic, can you identify the local max and tell me why? Yes, in theory, we can. In practice, we're going to do it. Okay, so where's our local max? 4, 8, and that's going to be our local max. And why do we know it's a local max? And why is it not global? Exactly. So we know we have a local max at 4, 8 because our domain is what? Because the domain, this is horrible, is from negative negative infinity to positive infinity. And we increase from negative infinity to 4 and decrease from 4 to 6. Okay. If it got any further, I don't have enough space to write, but you also could talk about how the rates, average rate of change is also changing. So then you also can talk about, is it concaved up? Is it concave down? In this situation, this is a local max and it's concave down because our average rates of changes are doing what? They are increasing, leveling, decreasing, right? Over that period of time, it'll be decreasing. You could also interpret it as what else would they possibly ask? That's it. They would probably throw in like a question about average rate of change and concavity. They would, because you need to say what the points are. So you have to be specific with your interval. Okay. All right. So that's our tabular reason. Again, what's the key thing that you should do when they give you a table? Draw a little graph, sketch it out. Okay. Do not feel like you have to do everything just from the table. I can't, I mean, I could, but why would I want to stress that hard?